Right, so screencast. Start with player.h, first header file, first defining the player.h, including your strings, and floor.h, taken from here, including vector and standard namespace. Creates a class player and lists all the available methods, all of which are public, as to be accessed from the main.cpp. Player.cpp, including strings, the header file, and namespace iostream, windows.h, and vector. So got the first constructor for player, giving a default name and the standard life count variable that I've included in floor.cpp, which will be global. We have the create player method, just getting to enter your name, and the name is used in the initial output, which is in the welcome screen. A getter for the life count. In player prints the welcome screen for the game and sleeps. Your name that you include at the top is now in the output for the welcome screen. It then returns 1 in main to the main, which will give the beginning, just displays a simple output, and a get line for a string. Yes, the character Y will return 3, bringing you to the next part of the game, and N, or any other character entered will return 9 and end the game. The ending scenario for the game is in this method, gives you the congratulations and simple outputs. The lose game scenario is another simple output, CA2, and displays the initial zombie ASCII character that I've put into the game, and just see out that you've lost too many lives. The second header file for floor.h includes player.h, so the methods are accessible, and including string. Creates a class floor and default constructor. The methods, again, they're all public as to be accessed from the main. Setting the cursor position for integers x and y, which will become evident when the game is played. And just the different methods and the endif. The floor includes both header files and Windows string, iostream, and stdio and conio. The arrow keys are defined as to the movement in the game, and a vector and iterator for the inventory are included in the globals as well as the life count. Here, the default constructor for floor, we want the player to start on the map at the coordinates 36 and 5 and reset the inventory to 0. The set cursor position, taking in the variables x and y and setting those coordinates and putting into an output handle. The first floor method, which would be the main part of the game, sets x and y and the cursor position. These statements here, they give different starting points on the map depending on how many keys you've collected, what your inventory size is. And then the floors print out and the cursor is set. There's a loop, which is constant, going through, and gets out a character which the user enters, which will be your up, down, left, right, and escape. Switch statement for case and escape to return 2 to end the game. Case right and all the conditions, so the player cannot walk through the walls, and creates a boundary for the game. Adds 1 to the x coordinate and reprints the screen, so it's constantly updating every time the key is pressed. These if statements check to see if the player is at a certain position on the map. being room 1, room 2, room 3, room 4, and the end space. So if your inventory is full there, then you can return 8 for the win scenario. Otherwise, you return the room number to the switch, whereas room 4 being 1, 5 being room 2, 6 being room 7, or room 3, and 7 being room 4. If you're not, if you do hit one of these positions, or if you hit the last position here, where your inventory size is not equal to 5, it will clear the screen and tell you that you need all the keys to unlock this door, and return you back to the last position that your player was at, that the cursor was at. So these if statements are for zombies. So there are 2 zombies present in the game which don't currently move, but hopefully for CA3 they will. Checks your X and your Y coordinate. If you've hit those spots, then it will reduce 1 to your life and return you back to the previous position that you were at outside the previous room. It's the same for all the other cases in this, being cases up, down, left, and right. These are if statements to check your position and whether you can move in a certain direction, giving the game boundaries, reducing your X coordinate, clearing the screen, printing in the cursor position. Again, the different rooms, checking to see if you are at a certain room. So this code is repeated so is that if you press up to go and you hit one of those one of the room doors, then it will be the same as you hitting left or right to get into the same room. There again, same for all of them, so the player can't walk through the walls. The clear screen method and the print floor, which gives the little ASCII map, which is top-down view. Something that wasn't in the previous version was I've added in the life count, so players can see how many lives they have at all times. That's coming from the global variable, and this was set to 3. X being your starting position, 0 being the zombies where you cannot hit, and the square being a room. Then we have the different room puzzles. So the answer, giving a string answer and presetting it, then giving the question to the user and asking them to enter their answer, creating a string user choice, and then getting that from the user. If your answer is equal, or if the user choice is equal to the answer, then for as long as your inventory is, it will tell you that you've collected the key if your inventory already has 1 stored in it, where 1 is being the first key and returning you to the last value. If you don't have this key already, then it will tell you you're correct and add 1 to your inventory. And tell you you've collected a key and gain a life, increasing 1 to the life count, and returning you back outside the room. But you could be wrong on the question, and it'll tell you you're wrong. And the game now includes a hint system, so it will check based on how many lives that you have left. So if you have less than 3 being the starting, then it will give you the hint after the second attempt. And it will take 1 off your life count and redisplay it. The life count is returned and put back here, so that is updating. If your life count hits 0, then it returns 2 and the game ends. The same goes for all other puzzles that are present in the game, using strings and getting the user choice, comparing them, and checking your inventory to see if you've already collected the key, where 2 being the second key. Moving to the third puzzle, and fourth. Moving to the main.cpp, so includes all your string, the header files, IOStream, and using namespace. You need to create 2 instances of each object, the player and the floor, and starts with the menu to run the game. Now p1.createPlayer, so you enter your name and then your name is added to the welcome screen. The choice starts off at 0 and the loop starts. In this loop is a switch where your case being between 1 and 8. So where each option is getting put out to the user and then each method is returning back a different value. So print welcome will print the welcome screen and return the value 1, bringing you to the beginning screen. So all the time clearing the screen, F1 gaining access to the other methods. And so on. The beginning will then return a 3 to bring you to the first floor, and all methods returning 3 will return you to the first floor and to the last position outside the room you were at. So the first floor, when hitting on certain parts of the map, will return different variables, whereas case 4, 5, 6, and 7, all being the different room puzzles, are returned from your position on the map in first floor. Case 8 being the clear screen, displaying the ending and sleep. So your loss scenario is included in the other methods and returning 0 by default. So we'll run the game. So you now enter your name and it will include that in the welcome screen. And we have our introduction to the game and looking for a character. X being your starting position and O's being the zombies. So we'll move to the first room. Well, you can't move outside the wall, so as I click right onto this wall, it won't let us because of the if statements. Now, the question is displayed and it's looking for your answer, and our life count is 3, so we'll enter in a wrong answer here. And we have 2 lives left. We then return back to the X coordinate, and our life count has changed to 2. We'll go back, and our life count is now less than 3, so if we give a wrong answer again, then it'll give us the hint, and we have 1 life left. So let's go back. Now using that hint, we're to use PEMDAS, so 40 plus 1 plus 40 times 0. PEMDAS applies as 40 times 0, meaning the answer is 41. And we gain 1 life and a key. Let's update it. Now the cursor position now starts outside of the room you last came out of, instead of returning you back to the X value. So let's go around to room 2. Is there for a second? We'll get this one right. Again, if you were to get that one wrong, our life count was equal to 2 at the time, so would display a hint. Now we'll hit a zombie, being one of the zeros where you're not supposed to be able to walk to, and we'll return you outside of the last room that you came out from. So let's go back into the other room and we will get the answer wrong. And now it will give you a hint as to what it is. Although you've already collected the key, you can still get the answer wrong. It does reduce your lives, but it makes no change on the inventory. So we'll go for another. The more you have of it, the less you see. And you're returned outside of that one. We'll go around to room 3. So you still can't walk through the walls. Say my name, I disappear. Now all the entries from the user have to be in lowercase letters. Otherwise it'll accept it as wrong. And you've beaten the zombie level. Thank you.